Hi, my name is Budumur Tejeshwar Rao. As part of completion of managing machine learning projects, I am assigned to create a project and record that. So my project objective is developing an application to suggest resource allocation decisions using the data and insights available for product pre-launch, launch and post-launch phases. As I am a pharmaceutical professional, I want to have a machine learning in place to make the decisions regarding resource allocation during pre-launch, launch and post-launch phases of a new chemical entity. So my project I have divided into 5 subheadings. One is opportunity evaluation, second one is crisp DM business understanding, third solution validation plan, 4 ML system design, 5 potential risks in production. So coming to the first part, opportunity evaluation. First I want to explain about the problem statement. So the pharmaceutical industry faces significant challenges in efficiently allocating resources during the drug product life cycle, particularly across pre-launch, launch and post-launch phases of a new chemical entity. So currently we are making decisions manually with some static rules, which which is leading to suboptimal outcomes in terms of budget budget use, personal assignment and market penetration. So as it is guided by the Coursera, I need to answer 3 questions as per the module 1. The question number 1 is there a problem? Yes, absolutely. The problem is complex. It's dynamic and influenced by various factors such as market trends, competitor actions and drug performance. So there is a problem to solve. And the second question is, can machine learning help solve it? I think yes, because machine learning can analyze large volumes of historical and real-time data and detect patterns and make data-driven predictions for resource allocation. The third question to be answered is, does someone care? Yes, stakeholders of pharmaceutical companies, healthcare providers and regulatory agencies are continuously forcing us to make cost effective decisions and and enhance patient outcomes. So there are few people who will consider this solution as significant. Coming to second part, crisp DM business understanding. So as per this problem definition, business objective is to optimize the resource allocation decisions during drug product life cycle by leveraging machine learning models that analyze historical, real-time and predictive data. So the key questions to be answered are, what are the most critical resource allocation decisions at each drug life cycle stage, and what factors influence these decisions, and how can predictions improve decision making accuracy and timelines. Coming to the success definition of this problem, so we are expecting some business impact with improved budget utilization, faster market penetration, better drug performance tracking and enhanced market share. The outcome metrics would be increased return on investment on marketing campaigns and reduction in time to market delays, and also higher prescription rates post launch. And our output metrics would be prediction accuracy of resource allocation models and percentage of correctly allocated resources. So the relevant factors which needs to be considered would be drug type, market size, regulatory timelines, competitor launches, marketing budget and historical sales performance. Coming to the third part, that is solution validation plan. The solution concept is, this application will use supervised learning models to predict optimal resource allocation decisions. It will process inputs such as historical sales data, complete reactions, and marketing campaign performance. So validation approach would be conducting iterative experiments with historical data sets, then test models using different feature combinations, evaluate models based on prediction accuracy and business impact metrics. That all comes under solution validation plan. And moving to the machine learning system design. So we need to design the machine learning system considering different options. The first option would be cloud or edge, and second option would be offline or online learning, and third option would be batch prediction or online prediction. So let's go deeper into these options and select one option out of each two. So coming to cloud versus edge, so decision is we need to go for cloud based system because it is scalable in case of data processing and integration with enterprise systems and ease of maintenance. Because of these advantages, I would prefer to proceed with cloud based design. And coming to offline or online learning, I prefer online learning because resource allocation decisions will require real-time updates and market trends along with the competitor strategies. So I would prefer to go with online learning. And coming to batch or online prediction, I prefer batch prediction because prediction can be scheduled at regular intervals, matching business cycles, and it will reduce the system load as well. So I will go with the batch prediction. So ultimately, our machine learning design would be cloud based, online learning, and batch predictions. Moving on to the potential risks in production. So potential model issues would be training serving skew. So differences between training data and real world production data may cause inaccurate predictions. That is one possible issue. And latency, delays in prediction generation could impact timely decision making. And data drift. So if the changes in the market dynamics or regulations, then they could reduce the model accuracy. And concept drift, the evolving nature of the drug product launches may necessitate frequent retraining of models. So concept drift can be a possible risk. So in order to reduce all these risks, we can have a mitigation plan where we can do regular model training and performance monitoring, data quality checks, automated alerts for data drift, and continuous integration pipelines for deployment updates. So these mitigation strategies will help us to prevent these potential issues during production. I believe this will help to enhance the decision making of drug product pre-launch, launch and post-launch resource allocation. I believe machine learning will be a great support and it's a great platform to make this type of applications which will enhance the quality and budget friendly decisions. Thank you very much.